wrote in a YouTube chat at least that we're having some technical difficulties.
Is it the YouTube connection that's not working?
Yeah, but I started, it's the scheduling stuff, but I started a new stream now instead, so it should work now.
Okay. So there's a new link, basically.
Yeah.
Yeah.
That's the result.
So let's see.
Seems to be working fine.
Yeah, good.
So a few people has found their way forward. Nice.
Yeah, looks good. I can see myself, and I'm just gonna tweet out the new URL.
Yeah, I think we're ready to go off that. And I posted to Discord as well.
Okay. Let's see. So we have some people here, with some people on the YouTube stream. It seems that some people have migrated from the old stream.
No matter what you do, there's a migration.
I think we were 16 people at the last one, so I guess we should give them some seconds to catch up.
Yeah. Okay, so Simon requested a joke. Who has a joke? Pontus, you have a joke.
Okay. JavaScript.
That's low.
I couldn't come up with a joke that quick, so yeah. That's one I have.
Okay, I guess we're now more on this stream than the old one is not working twice as much, so twice as many. So I guess we can get going. So let me just see if I can get this. Okay, cool. So I guess we'll start.
Yeah.
So welcome everyone to Recent Stockholm. This is our 4th meetup in this kind of new format, Corona format of doing things remote, which has actually for us been really good. We really enjoy these remote events where like there's so many more people that can join and from other places as well. So that's been great. So today we have Ulrich and Javier, who's going to give talks about 2 very interesting subjects. Ulrich's going to talk about building a certified OIDC client and the road to that, which has been not always straight from what I understood. And Javier's going to talk about an experiment he's done with server-side rendering React in recent ML native. So like very native and not JavaScript. And like before we get started, I'd like to mention that there's an initiative going on in the ReasonML Discord for an AMA. And for those who don't know what an AMA is, it's basically a session where you get to ask a person in the community anything, basically. Well, not anything, but anything related to the community. And David Sancho has launched an initiative together with a few other people on the ReasonML Discord. So I encourage you to go into the ReasonML Discord and check out the announcements channel, which has more information. I think the first AMA is going to be this Sunday. So we're all very much looking forward to that. And after the presentations, we'll try and do like a form of mingle at Discord, the ReasonML Discord. We'll post a link at the end of the meetup. So anyone who's interested in talking about Reason or anything else can join the Discord, the voice chat there. We'll try and have a good conversation there. I'll stick around for a while, and I think Pontus is going to stick around for a while as well. So we'll be at least 2.
Yeah, see you there.
Yeah, see you there.
Okay, enough of the introduction to the agenda. Yeah, we have some basic information as well. So ask questions. We have the Zoom chat, and we also have the YouTube chat. And we try to pick out questions that we think are relevant and good. And other questions can be left for later. And we don't want to interrupt the flow, so to say, of the speaker. So we'll try to ask questions whenever we can. And also, this is a recorded event. It's going up on the ReasonConf YouTube channel. And I think that's it for information. So enjoy. Here is Ulrich, the road to a certified OpenID Connect client in the ReasonML/OCaml.
Let's see if I can share the correct window here. Let's see, does that show up okay?
Yes, looking good.
Okay, so today I'm going to talk about OpenID Connect in OCaml and ReasonML native. About me, my name is Ulrich Strid. I'm at Ulrich Strid at GitHub, Twitter, and Discord. I work with DevOps at Zenit in Gothenburg, and we're building OpenID Connect providers and other fun stuff. And we're hiring, so come talk to me afterwards if you're interested. Trying to put native OCaml in production. So why do you want OpenID Connect? Well, it's an open standard. It helps you integrate easily with things like Facebook, maybe Twitter, I'm not sure, Microsoft, Google, etc. Auth0 is another good example of a OpenID Connect provider. And how does it work then? So there's 2 parts to OpenID Connect. There's the provider, which provides you with the login. So it's your Facebook, Microsoft, etc. They have a huge database with all the users. And then you have the client, which is your application. So you can go to Facebook and say that, hey, I want to integrate with you. I want you to keep track of the users because I don't want that in my database because it's sensitive. And then you just integrate via this open specification. Please interrupt with questions because I might be missing things. But basically, there's a few flows that the user goes through. I would speak about the simplest flow that's almost exclusively used in SPAs or single page application, which is the implicit flow. So you have the client or relaying party, as is the real name for it. And then you have the provider or the OpenID provider, which is the longer real name. So the client has a auth request that goes to the provider, and then the provider asks the user to authenticate. So basically, what is your username and password, which the user provides to the provider, which again is Facebook, Google, Microsoft. And when they have done so, the user will be returned back to the client with a ID token and an access token. So the ID token explains who you are, and the access token explains what you can do in the protected API. And then you're supposed to validate the signature. So this is almost always used in single page applications because it's slightly less safe than the more, the next flow. I'll just go to that directly instead of trying to compare them. So we have the authentication code flow, which is a bit more involved. It starts exactly the same. We send the user to the provider. They ask the user for credentials, but then they return them with a one-time code. Then the client will take this code. It will send it and some other metadata to the provider. And this is not seen by the user at all. So we have a secret that we share. And then we get the ID token, access token back to the client. Also, this is without the user seeing it. So there's less chance of man-in-the-middle attacks for it. And then we obviously validate the signature. And then we might use this access token to get extra details from the user info. So didn't I say OCaml? Why am I speaking about something that's unrelated to this? There's the OCaml OpenID Connect client library that I built and also certified, which is a process that I will speak about a bit. So the certification process is basically you build your library, then you set up some end-to-end tests against the OpenID Connect organization. Basically has some, they have both clients and they have providers, so you can certify either part against them. And then you just complete all these tests in the test suite, and then you send in your results. And then you'll either get, hey, you're certified, or no, fix these things. And it sounds very simple, but it's not. Okay, so why should we care about OpenID Connect? Well, it's very easy to implement with other providers as long as they follow the standard, which everyone doesn't. But I think more and more people are going this way. I know Apple, when they introduced their new Apple ID or whatever the name was, they did not follow the standard at first, but then they talked to the OpenID Connect certification group and fell in line to follow the standard correctly. So anyone can just use it. Okay, so what's my road to a certified client library? Because it hasn't been very straight. There were some libraries that are awesome. You should know that I started about 2 years ago working on things that related to this. Things that were there are obviously Mirage Crypto, or formerly known as No Crypto, which is a cryptographic library in pure OCaml. So you can run it on Mirage or anywhere basically. And it's used for OCaml TLS, which is a pure OCaml TLS implementation, which is very cool. There's also some smaller libraries that are very, very useful, like URI, Base64, JSOO, etc., that I'm relying heavily on. 2 years ago, there was also a lot of hype around HTTP-AF, which was this super fast web framework, but it's very, very low level. So yeah, but what was not there when I started 2 years ago, there were no solid way of working with JWT or JOTs, I think you're supposed to say, and JWKs, which is JSON Web Tokens and JSON Web Keys. There were a few half-baked JWT libraries, I think, but nothing included the key aspect of it as well, which is very, very important. There were no nice web story, at least not for me, coming from Node.js. Co-HTTP was said to be slow. It's not. It's faster than Node in every way, I think. And there were no nice cookie solutions since I wanted to use HTTPAF. So first I started to just try to build a HTTP provider, a OID connect provider on top of HTTPAF. But things start to get very hacky, so I broke out the first library, which is JSOO, or JavaScript Object Signing and Encryption. Previous work in this space was OCaml JWT and JWTO, which are two OCaml libraries to work with JWTs, but they were lacking, as I said before. Especially the JWK part. So the OCaml JSOO library is a very integrated library, and you have your keys and they work with the tokens and the encrypted the encrypted objects and the signed objects, etc., etc. It builds on top of No Crypto, or Mirage Crypto as it's now called, I guess, since the fork. This is something I've spent a lot of time on, and it's working nicely for me, at least. Is there any questions so far?
No questions so far.
Okay, great. It's clear as mud then, I guess. So the next thing is OCaml cookie, because I got very tired of working with cookies in a ad hoc manner. I found a really cool test suite from the HTTP state working group that has like 100 or so tests that were spread out in files that you can first parse the header and then make sure that you get the correct cookie. And I think vice versa as well. That was really nice to build a solid OCaml cookie library. And I think a currently modified version of that is merged into the Opium web framework. But we're working on moving those changes into my library to have it as a dependency instead, since we want to use one cookie library for multiple frameworks. And the last thing I built was Morph, which is a web framework that grew out of me trying to build this OpenID Connect provider that I started out with. It's a nice little framework, I think. At least for me, it's, yeah, you're working with middlewares and a context that you're passing through and adding stuff to. It feels a lot like the Opium framework, but it's based on Antonio Montero's awesome work with forking HTTPAF, etc. So these are the three major libraries I built, except for obviously the OpenID Connect library itself. Another thing that helped me build this is I lowered my goals. So instead of building a provider, I built a client. So it's slightly easier because there's less state to keep track of. It's immensely more useful for others because there's not that many people that actually want to build a provider. You often want to just integrate with someone else because you don't want to keep track of users. But it's not as cool, so there's trade-offs, I guess. A person that I couldn't have done this without is Antonio Montero, who couldn't be here live. He told me just before this. He has a well-maintained HTTPAF fork. He created the HTTP2 implementation and PF, which is a very, very good HTTP client that I'm using heavily in the OpenID Connect client library. There's also a server implementation in there that I'm using for Morph. And he also have given me a lot of feedback and pushing in different parts here. So now there's demo time. I didn't have time to prepare some cool demo, but something that is pretty cool that I can show you is how we actually do the certification. Oops, I need to log in. So this is one of the tests that we're going to do, or I did complete. So there's a lot of small tests that test different parts of the client implementation. And here I have my beautiful OCaml OpenID Connect client. I work mainly with design at Zenit, as you can see. Yeah, let's get to it. So this is the form post profile though. There's multiple profile that has slightly different implementations, and I should zoom it. Is this better? Anyone?
Great.
There's always a bit of a delay from the YouTube channel. I think you can increase it a little bit more. It's
okay.
Yeah, it's good.
I'll zoom this as well. Okay, so this is the form post basic certification plan. So this is implementing the second flow that we talked about, the code flow. So now we're starting a test. And now we can say that it's waiting. And there's also a bunch of output. So when I click here, there's also another part that I haven't talked about much here, is that it will actually register a client when I click this button. So it register a new client. So we don't share any secrets, and we don't share any client IDs that we have to keep in a secret store, because we just jump into it. Basically, we register it in memory, basically. So we get the secrets when I click the button. So when I click this, we will go to their site and we will be automatically logged in, because that's how they implemented it. And then we'll get back here. We'll have a ID token, which is here. I have also parsed it, so we can see the header part. This is just basic JWT. You have a header, a payload, and a signature. And the header is a JSON object that you base64 encode. The payload is also a JSON object that you base64 encode. And then you sign the header dot payload, and then you get the signature. And then you have your completed JWT, which is header dot payload dot signature. And then we also have the user info that I talked about that you can optionally get.
So we do have a question from Simon from the YouTube chat. He asks, which test was the hardest one? Any big problems?
So I think all the tests were equally hard, probably. There were some very weird edge cases, basically, that I didn't know of before, which was weird. I can't come up with what it was on top of my head. I think it was something with the query. It should have been, or the base, it was basic auth. So we do basic auth when we talk to the token endpoint, I think. But it wasn't pure basic auth. It was like a small variation. So it sometimes failed and sometimes worked. Luckily, we have great contact via Zenit with another OpenID Connect implementer that builds very, very good JavaScript libraries for OpenID Connect that could point me to like the exact paragraph in the OAuth2 spec, which OpenID Connect builds upon. That took me a couple of hours to figure out. Actually, Simon in the chat is my colleague and friend, personal friend. So we sat down one evening and we sat like until 2 or something, I think. It was very late at least, and just tried to figure this out. And then like the day after, I just fiddled with the parameters to the base64 library in OCaml and found or maybe it was the URI. Okay, one of the libraries. I fiddled with parameters and found out the correct parameter to make it just work, which was nice because then I could just delete 20 lines of code and didn't really understand. Yeah, so this is the completed test. So we have like a lot of success and infos, etc. And then we can see the nice passed checkmark. And if I were actually doing the certification now, I would download the logs and save them into a place that I know where they are so that I can send them in the email later. Yeah, so this is how you actually do the certification. And when you have your certified library, you will be in this list of libraries. So there's about 30 libraries in the world that is certified, and that includes multiple versions. So we're in a pretty small set of people actually doing the client stuff. And with that, I think we can go to questions.
Yes, we have a question from Simon again. Any plans of supporting PKCE? I don't know what that stands for.
And maybe start with what is PKCE?
Yeah, PKCE exactly. Is basically, in the code flow, you usually have a secret that is shared among the provider and the client. In this case that I showed, we're getting this secret when we register our client with the provider. PKCE, I'm not 100% sure how it works, but it's basically that you do some other, like when you start the authentication, you tell them that, hey, this is me, and this is a proof that it's me, basically, I think. And then when you get the user back with the code, you send the code, and then you send your proof back to the server. Something like that. This is actually mostly useful for single page applications. So it's not as important, at least for OCaml OpenID Connect, because it's a server implementation and it's okay to store the secret in a key vault or whatever.
It says here on the OAuth website, PKCE stands for Proof Key for Code Exchange, and it's an authorization code to prevent several attacks and to be able to securely perform the OAuth exchange from public clients. So, like you said, if you're doing this mostly on the server, this seems the most relevant for, as I say, public clients.
Yeah.
But if you were to implement that, would you have another test suite ready for you, like you've shown here? So you'd be able to, that looked very like, I understand there's a lot of edge cases, but that looked pretty convenient.
We can actually check what test plans there are. So there's multiple, as you can see.
Oh, wow.
I can't actually see something about PKCE.
Yeah.
Or Pixie. Someone said it's supposed to be pronounced. So no, I don't think it's there yet. It might not be a finished specification. I'm not sure about that. Maybe Pontus saw that when he read about it.
I mean, there is an RFC, but this is from OAuth, and OpenID Connect is built on OAuth. So this might be something
yeah,
from
so
OAuth, but OpenID haven't implemented it yet. Or...
So OpenID Connect basically adds who you are on top of the OAuth, what you can do stuff. So they should be the same thing, but you add the who you are stuff as well.
Okay.
Yeah, and there's some extra validation of the ID token, etc., that is all handled inside of the library.
Yeah. Okay. So we have a question from the Zoom chat from Max. Could you clear up the difference between a client and a provider again?
Okay, so the provider is your Facebook, your Microsoft, Google, etc. So they have the users and they implement that part. So then you as the client or the relaying party, it's also called, is your application. So you have a forum or something, and then you want to add Facebook login, then you'll use a OpenID Connect client and just point it to your Facebook application that you're creating in their development portal. Is that clear? The provider has the user and the client wants the user, but they don't want to handle them.
Yeah, okay. Max, you can respond. Yeah, he says, all right, thanks. We have another question from Reasonable Coding, aka Leandro, the grandfather of Recent Stockholm. He says, congrats. How much of OCaml did you end up using? Is it the core OIDC functionality? Is the core OIDC functionality purely functional?
Yeah, so the core is purely functional or purely OCaml without any, let's see if I can open it like this. So we have two libraries here. One is OIDC library. This is on OPAM today. It includes all the validation, etc. So this is like the core spec, basically. And then we have the OpenID Connect client. This uses Piaf under the hood, and this does all the talking to different parts. So we register clients here, we're getting the token, etc. And then as soon as their validation logic, it's using the OpenID Connect client, the OpenID library instead. If that makes sense, maybe.
Yeah, and for those who don't know, if you're more of a reason or a front-end code, OPAM is the OCaml package manager. So it's both, I guess it's both the repository and the client you use on your local machine to install packages. Yeah.
So if you're coming from JavaScript, it's basically npm, but it's not as easy to publish libraries because there's a manual vetting process, which I think makes a lot of sense because most of the libraries that are actually on OPAM is very, very good.
Okay, I hope that clears things up. Yeah, says thanks. So we have a question from Nils. This is very impressive. Can you elaborate anything about implementing cookie support?
Yeah, so when I started out, there is a cookie implementation that lives in co-HTTP, which is it's a web library or wherever, like HPAF or something like that, that provides you a server and client functionality, and it speaks HTTP for you, basically. In there, there's a cookie library that seems to be okay or good, but it's very much locked to co-HTTP. So if you want to use HPF or the H2 library for your server to get a little bit more performance, you have to build your own cookie library or do it ad hoc or copy the CoHTTP library from there with that license, which I'm not exactly sure which one it is. Might be LGPL or something. So I figured, after doing it ad hoc for a while, I figured that, yeah, okay, so it makes sense to actually break out the small snippets of code I have into a separate file, and then the file grew, and then I broke it out into a library and looked around for tests that I can use and found that test suite with about 100 tests or something, and just worked on making them pass, just one by one, making them green. It was a very satisfying way of working, actually, especially since I didn't have to write tests myself. I could just reuse someone else's work.
Sounds wonderful.
Yeah, so now there's a nice reusable cookie library for OCaml and Reason, which everyone can use. I'm not sure if Nils wanted to know more about it or what he wanted to know about it.
Let's see, there's always a bit of delay on the YouTube chat, so the direct communication can be a bit lagging.
Yeah.
But it sounded good. Nils, if you have any more questions, you can just ask it in the chat again. We have a chat in from the Zoom from David. He asked, what's the biggest difference between this and Cloud Elements? And I had to Google Cloud Elements and hope this is the correct thing. Drive, or am I cloud-elements.com? It seems to be some kind of API integration service with a fancy front page.
I'm not sure, but if it's anything like Auth0 as an example, then Auth0 is the provider part, and this is the client part. So again, the client is for your application, and the provider is for the one that owns the user data. Maybe I shouldn't say own the users.
So like your library is making it possible and easy to integrate OpenID Connect authentication in your OCaml or Reason web server natively, I guess.
Yeah, exactly.
That's the gist of it.
Yeah, so any provider that implements the OpenID Connect protocol, which is, again, Google, Facebook, Microsoft, Apple, I think, Auth0, which is, yeah, anyone can use that, and a lot of people have heard about them, at least. I'm not sure who else. There's Okta, I think, but they might be more enterprisey than Auth0, I think. But those are providers, and then you use this library to get their user data by the user actually consenting to giving it to you.
So let's see. We have another question here from David again. Right, but you implement the one client and the users can log in whatever the user decides.
Yeah, so you could have in theory multiple clients in your application. Let's see if we can get back here. So here we have two clients for two different certification profiles, but you could imagine it's Google and Facebook instead, or Google and GitHub, or yeah, whatever. So, but we're still using the same library and we're using the same endpoints. We're just pointing it to the two different providers, if that makes sense.
So yeah, we got an okay, sweet, totally from. And Max said, aha, now I get the difference. So Ori Hydra would be an example of an OSS OIDC provider.
Yes, I think so.
So have you deployed this to production yet?
No, I have not actually. I
Working on it.
might build this to just test the. We're building a OpenID Connect provider at Zenit that wraps Swedish BankID. And I'm thinking very hardly at putting up this as a test suite for when we're making changes there, basically. Yeah. And also as a demo site for potential customers. Also, nice. If you need BankID, contact me.
Yeah.
So it looks like we're out of questions, both in the YouTube chat and in Zoom chat. So then I can actually ask a question. So I'm lurking a bit in your repository. And I've noted this, to me, seems like a trend in the Reason/OCaml community, I want to call it. I didn't know about OCaml, and I discovered OCaml by discovering ReasonML. And I'm a front-end developer, so it felt natural for me, since you can say that React is like a first-class citizen within the language if you're using ReasonML or BuckleScript or SUNReScript and those things. But it seems the people that are going, could you say, further back the stack, doing backend things or terminal things and CLIs and those things. I see a lot of people starting off with doing it in ReasonML using the Reason native, whatever you want to call it. And then when they start doing something a bit more serious, in quotation marks, they usually move over to using OCaml syntax instead. Is there a reason for that? Is it because there's so much, like you said, OPAM, they have a vetting process for the packages. So a lot of the packages seem to be really, really stable and they're working. Is it just because of the familiarity with using those packages? Is there a difference between using an OCaml package with Reason or using just OCaml and OCaml packages? What's your reason for using OCaml instead of Reason?
Yeah, so I also come from JavaScript background and started out with Reason React, and then found the native speed very tempting, basically. So Morph here is still built in Reason, and I think it's 100% Reason. And you can publish Reason applications or Reason libraries to OPAM, because since Reason is also on OPAM, you can depend on it via OPAM, and it's fine. I think I switched over seriously to OCaml when I built my Jose library. As you can see on the links here, it's called Reason Jose because I started building it in Reason. And then I hit some weird Reason bug that wasn't fixed for a while. So I started converting it to OCaml. I think it was like something was not okay to write pub or something, maybe. Because there's public keys. So I switched over to OCaml, and I really like OCaml because there's less curlies basically, and I feel like the more I use OCaml, the more I like it. And yeah, I think it's a very nice language when you get to know it.
Yeah, and we're not like trying to put anyone on the spot or whatever. I mean, this is Reason Stockholm, but Reason is basically like OCaml. I don't tell everyone, but I prefer the OCaml syntax as well. And I like that the OCaml, Reason is still OCaml, and by using OCaml, you can be like a tiny bit like forward in the development of the language. And to me, OCaml feels like Vim or Emacs, like everyone hates it at the beginning. And then if you get over like the hump and you start using a bit more, you get familiar with the syntax. I think it's a pretty nice syntax. And I think as a person, I don't really care about syntax that much. I use curly braces for my day job, so it's nice to not use them when I'm programming for fun, or whatever you want to call it, basically. Like I like the Haskell syntax because there's like less syntax in the language. And I just like white space for function application. Yeah, but that's just, I was wondering. And you're using EC as well for the...
Yeah, I have not gotten around to learn OPAM for real. So EC is like an NPM workflow for working with native OCaml and Reason. So they talk to both OPAM and the NPM registry. So you can publish things on the npm registry and still use them together with open packages and in your native code. I have published the library on npm for a bit before I actually put it on open. So when I was churning on it a lot, I put it on npm, and then I put it on open when I thought it was more stable.
Yeah, and that's pretty much due to the vetting process, right? You can use an npm as a bit more like trying it out, just having it easy accessible, and then you feel it's like ready. You can put it on open, and like then you have a real trial or whatever.
Yeah, exactly.
Yeah.
Another thing that I can show quickly, I'm probably out of time severely.
Yeah, I think we're gonna have to move to the next presentation pretty soon. So, but if like take a couple of minutes and just.
Yeah. Okay. So we have pretty nice documentation in OCaml thanks to ODoc. So I've generated some pretty nice documentation here for the OpenID Connect client, which basically tells you in what order you're supposed to use the functions that are provided. So when you start up the server, you do some things, and then when the authentication starts, you want to use these functions. And then when you get the user back, you want to use these functions, etc. I just wanted to show that quickly. It's linked from the repo. So if you're interested in using it, this should be like a small guide of sorts on how to actually use it.
And is this something you've done manually? Is this help with the ODoc, the amazing tool we have, which can read the source code?
Yeah, it's ODoc. So I just added it as comments in the MLI files, the interface files, and then it's generated that way, and it works great.
Yeah,
so
awesome.
Thank you for listening to me babbling about stuff.
Well, thanks for babbling about stuff.
Yeah, it's been has been a fun project to follow through your process, and like you reaching all of the different other things you'd have to build to reach your goal has been pretty both inspiring and interesting to hear about. So it's I think it's common in the OCaml and Reason community to end up like that. Like you want to do something, and then there's a bunch of other stuff you got to fix first before you get there.
You start with to-do apps and you end up with OpenID Connect clients.
Yeah, or an operating system or something.
And also, if you want to learn more about Morph, we have a recording here from the last meetup on the ReasonConf channel called Reason Native Web. So check that out if you want to learn about Ulrik's Morph framework for doing web stuff.
Yeah, you'll have to get other presenters soon.
Yeah, you're a regular now. Yeah. Okay, so I guess we'll take maybe a 5-minute break and then get back to Javier. Does that sound good?
Yeah.
That's good.
Thank you.
Yeah.
Yeah.
Thank you.
So, thank you, Ulrik. See you back here in 5.
Can I share my screen? Okay, there we go. So we have this. Let's see. I was going to show this clap emoji.
Oh, yes. So
a small break. Let's take 5 minutes, and then we have Javier Chavarri coming up with the React server-side rendering with ReasonML/OCaml. And sorry for butchering your name, but that's the best I can do.
It's great.
Okay, perfect. So see you in 5. See you.
Hello.
Hey.
Hello. So do you want to share your screen? Get prepared?
I cannot start screen share.
Yeah, stop it. Let's see, can I test this again? Yes, because we had a test and we didn't have any echo then. Now there's no echo, okay?
It's okay?
I think so. Testing, testing. Oh, I can actually hear myself. We didn't have this problem in a test meeting. That's really weird. I think it's if we're talking at the same time, I think.
I can put headphones maybe.
Yeah, that would be great. I think that's...
Yeah. All right. Can you hear me now?
Yeah.
Yeah, sounds good. We can't hear ourselves as well. That's great.
Perfect.
Okay.
So I will start then.
Yeah.
Yeah, I think that was
Okay.
5 minutes. So whenever you're ready.
Okay. So hello, everyone. First of all, thank you, Gabriel and Pontus, for organizing the event and inviting me. Super excited to be here. First of all, my name is introducing myself. My name is Javier Chavarri. I used to do, like many others that mentioned before, I used to do JavaScript before at companies like Webflow, and then I got hooked into Reason in 2017, and then kind of went down the rabbit hole. And today I'm working at Ahrefs. I've been there for 1.5 years or so. We are also hiring, so if you want to work in a full stack OCaml product, there's OCaml on the backend and Reason on the front end. Feel free to, you can DM me or check ahrefs.com for open positions. So I will be talking about this experiment I did, which was try to render React on the server with OCaml. Also, there will be like a second part about what are the areas with high potential to share code between frontend and backend with Reason OCaml. And then we will go deep in one of these areas, which is share components with Reason React and anti-XML, which is an OCaml library. And this, if this allows to do server-side React rendering with Reason OCaml. Okay, so some context about the experiment. This was July of this year, and just after the Rescript fork news, so there were a lot of discussions about what was going to be the future of Java, BuckleScript, kind of like it had a lot in common with OCaml, what was going to remain in common or not, etc. And at work at Ahrefs, I had seen how powerful it is to actually increase the overlap between frontend and backend and with OCaml type system, because this gives you a lot of guarantees that you can encode on your code base that allow each team to make progress independently, but still maintain quality and kind of like be aware when you are breaking something that is not your area, etc. So I wanted to show what things, like if we have this goal of like, let's maximize code sharing between clients and servers with OCaml, where do we get? And as a side effect, I want to learn about how to deploy native Reason or OCaml applications in a simple way with Heroku or AWS. So I found this tutorial called A Lightweight OCaml Web App Tutorial by Sean Feather, and it is a great starting point if you want to learn kind of standard OCaml from scratch and build a simple web app. It uses Dune, OPAM, etc. Really, I don't know, like it's in detail enough, but very extensive, and you get a really good idea of how all the different parts work. But they didn't have any client-side complex logic. It didn't have any React or anything. So I thought, okay, I will start with this tutorial to learn more OCaml, and then I will try to add the client-side part with Reason React. So the stack more or less looks like this. We have on the server OPAM that was mentioned before as package manager, Dune, some database libraries to deal with Postgres, etc. Then XML, which is a library that we will go more in detail later. Opium, which is a web framework to create like APIs with native OCaml, and then the Opium router. On the client, we have npm or yarn, BuckleScript or Rescript now, Reason React for the UI, BSFetch, Reason React router, and Tailwind. So as you can see, all this is different, and there is no. This is pretty saddening to me because it's like you have a lot of reuse between BuckleScript and OCaml, and it's kind of like it feels like a missing opportunity to not share more things between these two stacks. So I have also seen like full stack projects like OCaml full stack, and they, for example, they use different encoders, decoders on each side. And in my opinion, this is kind of like risky also because each encoding and decoding solution care about its platform. You don't get like this unified experience. So what can be shared? The first thing I thought about was endpoints and interfaces types. So when you have an API endpoint, you have your payload, then you get your response, and this could be shared types between client and server. So for this, I used ATD, which stands for Adaptable Type Definitions. This project is now under Hrefs organization, but it was started 8 years ago or more by Martin Jambon. So it was put under Hrefs organization quite recently. It's a tool that derives OCaml boilerplate code from type definitions. So what this means in 2 minutes is that you have these ATD files where you have a syntax that is very similar to OCaml, but it's not OCaml, where you can define your types. You can use tuples, records, a lot of the available types in OCaml to define what you want to share. And then it has also great integrations with existing code. So you can defer some type, shared type to implementation in a module if you need more fine-grained handling of encoding, decoding. So how does this look like? We have our excerpt ATD file, the client and the server, and then we call ATD gen binary with -t to get an ML file with the types derived from that ATD file. And then -bs for the encoders and decoders. And then on the server, we do exactly the same thing with ATD gen binary. It's important to keep the same version on client and server to avoid conflicts or issues because, yeah, obviously, for each new version, you get new behaviors or something could change. The difference, so the types are the same, but the encoders and decoders have specific implementations. There is a special encoding for BuckleScript to support the types that are not available in that platform or are available in that platform. But essentially, you get a guarantee that you can use the same types. And this process can be embedded into the build process of each part. So bsconfig on the client and Dune on the server, so you don't have to call this ATD gen binary manually. And it becomes part of your build process. So back to the stack, we have server and client. And now this is not very super accurate. Like there's, I mean, one could discuss this diagram a lot, but the idea that I wanted to convey is that we are establishing some link between the server and the client through the language using ATD, in this case, Opium, and BSFetch. So all these endpoints exposed by Opium and consumed by BSFetch are shared now. So the second thing I wanted to try was routing. So we have the server-side routing, and we also have a router on the client with Reason React. So can we share the page routes between server-side and client-side routers? So enter a library called routes by Anurag Soni, which is defined as tight bidirectional routes for OCaml Reason ML web applications. This library, I want to point out, is one of the few examples of really first-class experience in both BuckleScript and OCaml, which is really great, and it proves that it is possible. The bidirectional here stands for the, so bidirectional in the sense that you can have a pattern, you can have a set of routes, and then you can take a string from the specific route the user is querying against. You can match against that set of routes, or you can also use the routes as formatters, so you can produce strings from those routes for whatever you need. So this is kind of the bidirectional objective on the definition. So how do shared routes look like? I implemented them as a functor. Maybe there are simpler approaches, but essentially you have a list of routes. You pass some handlers as the parameter of the functor. By the way, I'm using Reason syntax. If you go to the code base, you will see a mix of OCaml and Reason, but I thought it was better for consistency on the presentation. So the handlers have to be defined on both the server and the client. You have, for example, pages hello is the function that handles the root hello plus another string. And then there's a hello fallback when there's not parameter. And these, let me see, the s, empty, etc. These are functions defined in the routes library to create the routes. And then these infix operators also are part of the library. I think it's pretty intuitive what is going on. Essentially, the root is on the left side, and then if the root is matched, then it goes to the handler on the right side. And then, well, this functor is called twice. This is one example of a handler on the server for the excerpts by author. So it does some query to the DB, and then it renders a page with payload. So I will talk more about this later, but essentially for Reason React to be able to use hydration, it has to get the state of the page as the server rendered it. So it needs to know the excerpts. It could do a query, a request to get the excerpts, but in this case, we are using ATDGen. If you look here, we are getting a string of payload from the list of excerpts, and using the encoder generated by ATDGen to put that on the resulting HTML from the server. And then we pass a shared component, also page excerpts, with the actual HTML of the page. So because we're using hydration that we will talk about later, we have to send the raw data as well as the HTML. And this is how the client would handle the same route. It checks for the payload. In this first case, if there is a payload, that means this is the first page that the Reason React application is encountering, because we remove the payload after this first render, and then the React application takes over. And essentially, it uses ATDGen again to encode the payload, and then it just passes the list to the exact same component that the server is using. And if there is no payload, then that means that, I mean, we could use caching here or other mechanism, but it means that we are navigating through the page. So it just fetches the excerpts and then render the page. Okay, so we saw routes, and now the stack again. We had ATD, and now we have routes between both the Opium router and the Reason React router. Okay, is that more or less, I don't know, if there's anyone that wants to ask something, please interrupt, because I'm not reading any messages, so.
Yeah, it looks, the chat looks clean. I also, it's not a question anymore, but so basically what you're doing is that the A to D is your, you can say your type definition that's shared. So that's your source of truth. And then you're actually using that and compiling that to the types, both for the client and the server. And that immediately got me thinking of it kind of working like, I'm thinking back to Sean when he talked about OneGraph and GraphQL, how GraphQL schemas work, that you compile your schema and you have to check in the schema into the source code. So that's actually you, like it's kind of, that's at least when it got me thinking about that. Like you're compiling your types and you use them and you're checking them into the source code, I suppose, and you're referring to them as normal files. Just the source that they're coming from is the A to D. You don't write the types yourself in the ML or reason syntax.
So in that sense, ATD and GraphQL are similar in the sense that you are kind of creating a higher layer that you can use to share types across different boundaries. The huge difference, in my opinion, is that ATD-Gen is way less ambitious or way less prescriptive with what you have to do with, because it has less responsibilities. So essentially, you can use ATD in any kind of context. It doesn't tell you how to. I mean, you can use REST API, but you can. I guess you could use any other mechanism like WebSockets or I don't know, whatever. It's just a shared type, right? You don't have resolvers. You don't have. So while with GraphQL, you are bringing a lot of friends, like they say, like I don't know, maybe you need to data loader for performance. You know, like it has this kind of like tail of things that you have to maybe consider if you adopt it. ATD-Gen is way less. Way less ambitious or way more minimal. So it does one thing, but very tiny, and it does it well. So I guess it depends on your application constraints or your team knowledge, etc. But I generally, after the experience with Ahrefs, I really like ATD-Gen because it adapts to your needs. It doesn't require a lot from you. So that's pretty great.
It sounds a bit simpler. So you basically just have a checked-in file that says like user type, and there's a comment above like generated with A to D, and this is version 0.4. Don't edit this, and then you have to go on with your life. And there's the same file in the server that's an ML file instead. It says the same thing, and it's the same type, just represented with the OCaml syntax instead. Is that correct?
Exactly. Yeah. I mean, it always produces OCaml syntax.
Okay.
Yeah, I never look at the generated code, honestly. Like I just know that the types are there because I'm typing them on the ATD files. And the specific thing that it produces on the BuckleScript side is, for example, if you use, I don't know right now, but there are some differences in the way, for example, in 64, right? It's like a native thing. So I think it's available on BuckleScript, but it's encoded different than in OCaml or something, you know? So it takes care of all these runtime representation differences between BuckleScript and OCaml, and it just figures them out for you. There are some edge cases that you have to be careful about, but in general, you just you find the types and forget.
So we have a question from YouTube, from Reasonable Coding, aka Leandro. Is there any reason you don't go full gRPC and with it assume that payload received from the API are well typed?
I guess, I mean, what does it mean that they are well typed with ATD? No? I guess. I'm not sure if I understand.
Maybe I can chime in here. So I think actually gRPC would be very much like ATD, but instead of .atd files, you will create .proto files, and then you will generate the code on both sides. So yeah, I think it's the same thing.
It's similar, no? I mean, I'm not very familiar. I know a bit about protobuf, but essentially you have a single language that can auto-generate code on 2 platforms or 3 or whatever. Like I guess gRPC you can generate for a ton of different languages. ATD has support for OCaml. I think it has support for Java as well, BuckleScript. Yeah, I guess it's more, ATD is more fun or closer to OCaml, or it has a longer story of like integrations, etc. But yeah.
Yeah, and I think that's a good
reason.
argument for a lot of people, like familiarity. It's more familiar to you, so then you use that tool.
To me, honestly, that was the reason. Like I was just used to ATD at work, so I went with it. I have tried it very thoroughly. It works really well for us, at least. So yeah.
Yeah, I mean, it's something it's familiar and it works. Like it. Yeah. It's good. Keep doing what you're doing.
Right.
Is there anything to handle like, I guess not migrations, but like deploying the front end and back end separately, and types start to differ and you remove fields and those things? Like, is there anything built into ATD Gen for handling that gracefully, or like evolving the kind of schema or what you want to call it separately without having to deploy everything that uses the code at the same time?
I'm not sure. I'm not aware of it. The way we do things now is more like atomic. So as you say, we guarantee that like if there are any migrations to be done, we do them manually, and then we have this guarantee at all times that all the sites have the same types. But I would need to check the docs. I mean, what I know is that ATD is very extensive, so there's a lot of functionality. The documentation is really good, and there is a lot of functionality there to cover a lot of cases, different cases. So maybe there is. We'll need to check.
Yeah, I think we can continue that discussion afterwards if people want to stay for the mingle, because we're getting a bit short on time here, so we can continue with the presentation, and then we can keep guessing that later. Okay, sounds good.
So okay, so we saw ATD roots, and then the third part was share components. 2 questions: can React components be rendered server side without JavaScript? And can we have the exact same component be compiled by both OCaml and BuckleScript? A little tiny reminder of server-side rendering with React. Essentially, it's taking a tree of elements and converting that to a string, right? So I will mention it in a few slides, but well, yeah, essentially, you could do this with any language, provided you produce this string and you don't need a lot of functionality from JavaScript, right? The other thing I wanted to mention briefly is hydration, which I briefly touched before, but essentially, without hydration, what we used to do is send a small HTML from the server. It renders on the DOM, and then we get a React application, and that React application will create a bunch of elements, which means a lot of updates on the DOM. And then at the end of the mounting process, it attaches the event handlers. The problem with this is that the element creation or touching the DOM is the slowest part of the process. So when people started using React on the server, they started wondering, what if we return, like we have the same code on the server and the client, we render the code on the server, and then we just hydrate the application on the client. So here I'm representing the application, like you have more HTML coming from the server. The DOM, the browser will do the first render, then we get the React application. And in this case, with hydration, we don't need to touch the DOM. React will just say, okay, I trust that if you call React DOM.hydrate, it will trust that the server rendered the appropriate HTML and just attach event handlers on the events on the elements that require. And this is a much faster process because React does not have to modify the DOM. However, before continuing, I am using hydration for experimentation purposes, but in production environments, I would say that is rarely the best solution. generally you have either SEO first, like public applications, where what is very important is to render fast. So you want to remove as much React on the client as possible, and as much scripting as possible, and just render as much as you can on the server. Or you have the other kind of applications where SEO doesn't really matter. So you can just render like shallow HTML pages, skeletons, and then mount heavier React applications on the client, because like time to interactive is not that much of a constraint if your users are going to be engaged for longer time. So just wanted to mention this, that I think hydration is cool for exploring this goal that we have of sharing code with OCaml, but there is more info in this article, Rendering on the Web, that I recommend. So Dan Abramov a couple of years ago mentioned that React DOM server, it doesn't need a reconciler, so it's a really small part of the whole React library, and it could be rewritten in another language. I was thinking on using Reason at that time already, but the issue is that I'm a bit lazy. I don't have a lot of time, so I was thinking, okay, how can I hack around this full reimplementation of React DOM server in OCaml or Reason, and just skip to the next stage, which is testing these ideas, right? So this is where TyXML comes in, very handy. It's a library for building statically correct HTML and SVG documents. What this means is that if you try to do something like that, what we're showing here, like putting a div inside another list, the type checker will tell you, like the compiler will tell you that this is not a valid element. So this is super useful, and this is something that I haven't found in recent React at least. So so share components, this is how they look like. We will go now on more detail of each one of the parts, but they look pretty familiar if you are used to recent React or TyXML. Maybe with recent syntax, I don't know if TyXML users are more OCaml. I guess they use OCaml a lot, but they start using Reason as well, because it's more, I guess it's more ergonomic if you're rendering a lot of elements. So challenges that I found while I was trying to compile. So this component is rendered by the OCaml native and BuckleScript on the client. But there were some challenges. Let's see. So the first one was create element versus make. This is very obvious and trivial, but TyXML PPX. PPX is the preprocessor that converts the brackets syntax on the left to the actual function call on the right. TyXML converts that to foo.createElement, while recent React does foo.make. So, okay, this was kind of like, I'm not going to spend a lot of time. You could patch each of either TyXML or recent React PPXs. I just defined both createElement and make and moved on. One called the other. Yeah. The second challenge was platform-dependent shims. So what do you do if you want to use code that is only available on the client, but you still want to keep your component rendering on the server, and you don't want to break it down into smaller parts because you want to keep things together, etc. So what I ended up doing in this case, for example, I defined some shims on the native side that do nothing. They just render, like they return unit, but they allow the code to compile. This is not super elegant. I don't think it can be stretched a lot more, but it worked. And there are other solutions that we will see now that can maybe used in the future. The next challenge was event handler. So TyXML is for, like, let's say plain HTML elements. So it doesn't support React events like on click, on mouse move, etc. So what I did here was I patched very slightly the TyXML PPX to support these attributes first. And then when the PPX finds them, it just removes them from the AST. So what the server side binary is going to read actually is the component on the right without the onClick attribute. And this is really cool because of the schemes we were discussing. So for example, everything that is inside this event handler doesn't need to be implemented as a scheme because the backend doesn't really see it, so it will compile. So that is great. The downside is that you get warnings for unused variables. If, for example, you have your component has a prop and you're using that prop on the event handler, then the compiler will tell you, hey, you have like, I don't know, URL here as prop, but it's not being used, but it is being used, but you're removing it. So I worked around that with underscores. I don't know, maybe there are better ways. And another challenge was children handling. So in XML, you can do stuff like this. With the spread operator, you can have a list of elements, wrap them with list map. Yeah, as you can see here, well, there's an underscore on the I probably because, I don't know, I guess I used it in some event. But the problem is that recent React removes support for the spread operator in JS6.3. What the spread operator does very quickly is to tell the XML PPX, this is already a list and you don't need to wrap it. Because otherwise, if you just have one child, then the PPX wraps it into a list. So all the children are always lists. In recent React with JX3, they did some, it's kind of like a ambiguous typing in the sense that children can be either one element or a list. And then because this is like the binding boundaries, they do some hacks using the React.js API. But long story short, the spread operator is not available there. So I had to work around that in different ways, patching the XML, etc., and using wrappers. But in the end, it worked. So again, with the stack, we can see that we had 8B for the API endpoints and routes for actually showing the routing. And then we have shared components for XML and recent React. So what was before like a very strange or foreign stacks, now they start sharing more things. So my conclusions is that there's a lot of opportunities of code that can be potentially shared between backend and frontend. ADD for the binaries, routes library, React XML for shared components. And the type checking and across boundaries and teams, in my experience here, it has a lot of impact in how an organization can work more like faster and without removing process essentially, because you need less meetings when your compiler is telling you that you break something. Like I know that meetings are needed, but essentially we are working now on this remote environment, different time zones. So if you have more help from the tools you use, then the better. And this is, it is working. This is all the code or the modules that are being shared on the app. You can see on orange, the components, on purple, the ADD files. And then on, I don't know what color that is, you can see shared code that I just wanted to reuse as kind of library code. So future work, the XML integration with recent React could be improved and maybe make official at some point. We can replicate. There is also a very interesting thing that React is doing a lot of stuff on the server side to make sure that hydration works. So for example, if you have two string children next to each other, after that is rendered into a string, then the client side has no clue if this was one element that rendered a string or two or five, or it doesn't know. So React.js, it injects some HTML comments between string children. That is kind of one thing, but it does a few things like that to make sure hydration can happen. So maybe XML could replicate that as well. And on the other direction, maybe take the parts of HTML validation and then apply them to recent React. I am really interested these days into JSOO of OCaml, which is it fills the same gap as BuckleScript in the sense that it also produces JavaScript code from OCaml, but it is implemented in a very different way, which is farther from JavaScript and closer to OCaml, let's say, to make it short. So I am working on bindings to React.js with JSOO of OCaml, and I want to explore a similar setup that the one that we discussed with JSOO of OCaml React. And then when this idea is more mature, maybe exploring integrations with frameworks like Morph or Seal that are being developed and are super interesting. Resources, I wrote a blog post about these ideas we discussed. There's the source code of the app here. I mean oops, no, this is not gonna work, but the app can be seen in Heroku if this loads. Yeah, so this is the app. We can go to any page. So now I'm navigating on the recent React application. We can see like here some API queries being done, but if I refresh this page, I get, you know, like HTML response, which is with the same content that we were seeing before. So you can do, I don't know how to call this, but universal rendering or client and server side rendering, whatever. And then, yeah, so any ideas, contributions, hacks, questions are welcome. I want to mention that I think it's important to strive for quality and like to ship great products, but I also think there needs to be some experimentation. Like I have the impression lately that there's a lot of weight on the first side, but not much on the second side, which is experimenting. And maybe what we were saying, like hydration is probably not the best thing to use in production, right? But that doesn't mean that you cannot do an experiment using it for the sake of achieving another goal that you want, or yeah. And I think that's it. Yeah, thanks a lot. And if there are any questions.
Awesome, thank you, Javier. We have a little note from Ulrich. He says that note that the children handling is bugged in recent React, and Thai XML is actually handling it correctly with quotation marks.
Yeah, I mean, I think the intention of this, it is a bug in the sense that you have a thing that has two types, which is not possible. I mean, in theory, you cannot have something with two types in OCaml. But this is as I was saying, this is kind of like the binding boundary. So on the bindings boundaries, types are more flexible. And I think the reason they did this is that it allows you to not think about the spread operator. So I take it as more like as a user experience thing. So they were saying, okay, in which way we can remove the spread operator. I am pretty sure that there's a new pragma that is coming in React 17, the JS6 pragma. And that changes the way children are handled on React.js. I am pretty sure that they will have to come back to the previous approach with the spread operator, because you can, in React.js today, you can pass children in two different ways, as part of the props or as part of the variadic parameters that you pass to the create element call. But that goes away with the new pragma. And that is the hack that allowed the recent React team to say, you can have one child or a list of children. So yeah, I mean, I don't think it's a bug in the sense that I don't think it was unintentional at all, because if you use the spread operator, you get a warning from the PPX. So I'm 100% sure this was intentional. Then we can discuss about if it is a bug in the type system meaning, but I think it was intentional.
So bug might be the wrong word, but it's a hack at least.
Yeah. A hack, yes. It's a hack.
That's what I say to our testers
Yeah.
when I've implemented something. No, it's not a bug. It's a feature or a hack.
Yeah,
Or,
it's a
The hack. Yeah, that's great.
yeah.
like the bug label in Azure on our board.
So a question and a suggestion maybe. Have you looked at using the functors in TY-XML to make the React DOM implementation? So you can functorize over TXML and give it the React implementation, and then you can use that PPX instead of the React PPX to make everything nice and typed, and you also get props for free, I think.
Yeah, I haven't. Okay, so you can like add new props, for example, or the stuff that I was doing on top of the main TY XML, you can do it with a functor, right?
Yeah, so there's the XML functor, the SVG functor, and the HTML functor, and they all build upon each other. So you can provide your own XML implementation and then functorize over that. So you would implement React XML basically and bind that to the React.js. And then you functorize the others on top of that. So then you can use the TY-XML PPX to be React basically.
I haven't looked, but yeah, that sounds like I think it would be, yeah, it would be probably more productive to test all this stuff with JSOO for OCaml. And yeah.
You could probably also get a lot of help from Group if you ask him. He's
awesome.
very helpful. You just have to nerd snap him.
So speaking of JSOO for OCaml, since you've experimented a bit with that and bindings to React, I was thinking, could you maybe talk a bit about JSOO for OCaml as compared to BuckleScript and Rescript, and kind of like what the difference is and why you'd want to use either of them, kind of, or maybe since I guess most are familiar with BuckleScript, maybe what's interesting about JSOO for OCaml in the React kind of context.
Yeah. Okay, so like the first thing is the design decisions that are different between JSOO for OCaml and BuckleScript. So JSOO for OCaml is older, and it's in time, like I think it's from 10 years ago or something. And the idea was to have produced JavaScript code without having a lot of maintenance burden added to it, right? Because OCaml community, at the time at least, the reasoning, if you read the JSOO for OCaml paper, there were a lot of OCaml projects that were trying to produce JavaScript, and they would die eventually because they were trying to fork the compiler from a very early stage. So JSOO for OCaml proposal was to say, we are going to take OCaml bytecode compilation output and convert the bytecode to JavaScript. And that is a much lighter kind of, or less disruptive approach than if you start earlier in the compilation process. And the BuckleScript approach was to say, we can handle the maintenance burden, and we are going to fork from an earlier stage. So BuckleScript actually starts forking the OCaml compiler from early on, and then it can do things that are impossible to do by design on JSOO for OCaml, right? Like I don't know, all kinds of optimizations that BuckleScript can do at the type conversion levels, etc. So JSOO for OCaml, you get, for example, more conversions between types. So for example, because they are represented as in OCaml native. So strings, for example, are not string to string. You have OCaml strings, but then you have JavaScript strings, and these are two different types. So you have to keep this in mind when you write bindings. like you do with other types in BuckleScript. If you convert like lists and you have to check with JavaScript, you have to convert to arrays. So you add a few more types to the list of differences because of these design decisions. And to me, the most appealing part of JSOO for OCaml is that, well, first of all, it's very stable. Like it's really, I think it's very rock solid. It is used by companies like Jane Street to do all kind of like complicated websites for their clients. And it also follows very closely the trunk OCaml compiler. So the main maintainer of JSOO for OCaml, every time there is a new version of OCaml, in few weeks or like, I mean, months, let's say, but 1 month or two, you have the version, new version in JSOO for OCaml. And the other reason that is very appealing to me is that it feels very well integrated with the rest of the OCaml ecosystem. So if you are using OCaml on the server, like all the presentation, what we were discussing, then it is very natural because you can use Dune on both sides. You can use OPAM or SE on both sides, but essentially you can, for example, there are many questions in BuckleScript that I have asked and many others about, can I use PPX deriving or can I use this other PPX? And then it's always a struggle, right? Because you have to take these projects that are created for OCaml and either rewrite them or rewrap them. Like for NPM, you have to solve all these issues. And to JSOO for OCaml, you can send mostly everything. Like if you have your OCaml native project, you want to, I was talking to David, who is connected the other day. He has this query JSON project that is amazing. And he wanted to run it. Maybe I'm doing something wrong. Maybe I'm telling something that I shouldn't. I'm realizing now, but
it says it's fine in chat. So
yeah, this is like for insiders only. So so essentially, there was this huge OCaml native application, and you tell Dune to build it for JavaScript with JSOO for OCaml, right away, you know, like all these native libraries, everything compiles in JSOO for OCaml. So that is super appealing, obviously, if you're using OCaml on the server. I would say if you just want to, for example, use Node and JavaScript, I would probably say that BuckleScript, you're going to have a much integrated or close experience to JavaScript, just because, yeah.
But is it fair to say that it kind of just works then for the native kind of the OCaml universe, so to speak, or is it? Because I mean, BuckleScript has, yeah, like you mentioned, there's a lot of hoops to jump through depending on what type of thing you want to use from the native land. But as I understand JSOO for OCaml, things just kind of work from the native side of things, at least, like libraries and approaches. And
what I'm interested, and I've been learning, I'm mostly a noob in JSOO for OCaml, but I am trying to learn how to, like, there are many good things to learn about BuckleScript in terms of writing bindings experience, what things are complicated or not. So I am learning more about how all these things could be applied to JSOO for OCaml. So in terms of writing bindings or make the experience simpler, there is a great project called Gen.js API that allows you to kind of forget about these type conversions that we were mentioning, and you just say, okay, I have this function that takes a string in JavaScript, and then Gen.js API will generate all these conversions for you. This is also another thing, another downside of JSOO for OCaml is that you probably will end up with, well, mostly you will end up with larger bundles just because it cannot optimize as much as BuckleScript. But yeah, I mean, it depends, right? If it fits your use case, if you're working with OCaml on the server, or your, I don't know, your company is heavily invested on OCaml, then it makes a lot of sense. If you need like super light bundles, or like you are using 20 JavaScript libraries, then probably better to use BuckleScript.
That's the thing I've noticed, like BuckleScript is really good at optimizing the size. And like, I think that's more of the focus of BuckleScript, whereas like JSOO of OCaml, like you said, is stability. And I think it mostly just depends on which side you come from. If you come from the OCaml side, I think JSOO of OCaml comes more naturally. But if you come from the JavaScript side, I mean, the reason is basically there for JavaScript developers, like curly braces and the NPM flow. That's why we have easy as well. And it's optimized for, I guess you could say, front-end development. The BuckleScript, like it feels more front-endy.
Yeah.
Yeah. Well, like you said, like Yainstraight, they have a lot of stuff. You can scroll through their GitHub. They have a library called Bonsai, which is like a framework for building dynamic web application. Have Inkerdom, which is a library for based on their own virtual DOM.
Right.
They have something called, they have a lot of stuff for building web applications. I guess they're just, they're not really on that like JavaScript hype training and marketing it as much. But
I guess like with JSOO of OCaml, you better kind of forget the idea about what you're putting into the compiler somewhat matching kind of what you do by hand or yourself in JavaScript. I guess that's the kind of thing that's, and by not trying to cater to that use case, I guess you can do all sorts of cool stuff as well.
Right. Yeah, I think the current JSOO of OCaml users, they don't have a strong need of using libraries, existing libraries in the JavaScript ecosystem, right? So I don't know, like maybe their use cases, if they need charts, they just implement their own charts library. I don't know how that works, or maybe they have, maybe there are existing OCaml libraries that they can use for that.
It's amazing that you don't need Lodash or Ramda when you have a good language to begin with.
Right.
That's a bit tongue-in-cheek joke, but yeah.
Yeah.
What I mean.
But really, this is cool. For example, that you can get all these like let operators from native OCaml. They are available with. You can use LWT, which is this amazing asynchronous handling library in OCaml. Yeah, in general, it feels like if you're doing OCaml and BuckleScript, there is a lot of rough edges around the build tooling, etc., because they don't talk to each other essentially at that level. And JSOO of OCaml removes all that. Like, no, you can reuse June files. You can reuse code on both sides, etc. So.
There are a few like really cool examples that's been floating around for a long while with JSOO of OCaml. Like for instance, Flow, the type checker, which is written in Flow type checker for JS, which is written in OCaml, and they've been like their playground, which mimics, or rather, it is Flow, like that they're actually running in the browser, but it's actually OCaml, kind of just compiled through JSOO of OCaml. That's also really cool that they can basically just compile it to JavaScript and make it work.
Yeah.
With from what I understand, not too much hassle, kind of.
The ReScript playground, all BuckleScript playgrounds are compiled with JSOO of OCaml.
Yeah.
Can I interrupt? I think we need to wrap this up soon. We're 23 minutes over time, but it doesn't really matter. But like Ulrich said, we could move this to the Discord pretty soon and continue this discussion.
Yeah.
I just want to make, it's not so much as a question as it is a statement, but you showed your tech stack there, and you showed us that you have Tailwind for styling. And I just want to say how amazing Tailwind is. We'll be doing some internal stuff at my client, and we toyed around with Blazor, which is just worse React on the .NET stack that runs on WebAssembly, but it doesn't really support WebAssembly yet. I don't know really, so we're rendering it on the server. But that's a thing that's I think is really nice with Tailwind when you're rendering things on the server. You just add the class and everything works. Because I can imagine how hard it is to do. There's a kind of like CSS in JS solution and have that render on the server, and I don't even want to think about it. With Tailwind, it's just like it works.
I guess David would solve that for you with his CSS PPX.
Yeah. It's harder when you're doing .NET though, but yeah. I just want to give a shout out to Tailwind.
All right,
it's
yeah,
been
.NET,
a blessing. So,
harder.
but I think that wraps up this meetup. I'm gonna be a professional meetup organizer and share my screen here so we can move to the last slide. So let's see, yeah. So thanks to all the speakers. Thank you for coming. Thank you for taking your time to prepare this and presenting to us. It's been amazing. And
thank you for having us.
Yeah, thank you. And here's the link to the Discord, discord.com. So I think that's the link. I haven't actually verified it since I'm already in.
Live.
No.
Oh no.
Is it discord.gg/
Let me see if I can
ReasonML, or you might be able to
invite here.
Use your wizard brain and invite some people. Is there anyone here who wants to join us and is not on the Discord?
I'll paste the link here in.
Let's see, I need to go back to this.
There's a link to
Never
the
testing
Discord.
production.
Yeah, well.
Okay, there's the link.
Sometimes you get lucky. I mean, it's.
Is there another way?
And let's see, just one last shout out. So Reason Stockholm, we're not really Reason Stockholm. We just want to see what you're doing with Reason and OCaml. So don't be afraid. Just show us something fun you've done. DM us, Twitter, Discord. Here are our tags, and we're also in the ReasonML Discord and probably in the OCaml Discord as well. You can search for our name there. I'm Pixel Hero, aka Pontus. We have Gabriel, goes by ZTH with a bunch of underscores.
Yeah, that's not very thought through, the number of underscores.
But you can probably search for Pixel Hero or Gabriel on the ReasonML Discord, and you'll find us there. And you can message us if you want to present anything, just everything from hello world to like type level magic or whatever. We want to see everything.
Just live coding or whatever, it's all fine.
We just want to spread the gospel of Reason and OCaml. And I think that's it.
Yeah.
So again, thank you to all the speakers, and we'll see you all at the next one.
Yeah, and Discord, of course.
And Discord in a couple of seconds.
Yeah. So maybe I'll paste the Discord link. I pasted it in the YouTube stream, and I'll paste it here in the Zoom chat as well. And we'll leave this Zoom meeting up for a little while, so we don't remake the last mistake of shutting it down right away.
Yeah.
But otherwise, let's hop over to Discord. See you there.
Yeah. We have a voice channel there called the General. Dave is already there. So just jump into that one.
Great,
perfect.
Dave.
Okay. So are we shutting down the stream now and everything? Yeah.
Yeah.
So take care, everyone. Stay safe, and see you at the next one. Bye.
See you.
See ya.
Bye.